So here's our third and basically final lesson on polynomials. There's one little tiny topic that we haven't hit, and I'm just going to do a separate video. In fact, that's what I was just working on now. I'm going to do up on that, and I'll just post that and send the link to anyone who wants it, just on one tiny little idea, which we've really basically actually already done in other situations. So this one is an important one, though, this polynomials 3. This is kind of the main type of factoring that you run into. The ones we did last time also definitely come up, especially the common factoring, which you might remember we always look for common factoring first. And the other two types we did last time, we did grouping and difference of squares. They come up, but not as frequently as what we're about to do here. They're all important, but this one's extra important. So just before we jump into our final type, let's just remind ourselves what factoring is, and I think I have a couple review questions for you to try. So remember that for the first half of chapter 6, we expanded brackets, and now in the second half of chapter 6, we are trying to undo that process. We're trying to go from something that is unexpanded and turn it back into bracketed multiplication. These are the three that we've done so far: common factoring, factoring by grouping, and factoring a difference of squares. And why don't you just take a couple minutes, see how much you remember from our last lesson on how to do these three. Okay, let's take a look at these and see how we do. So on the first one, common factoring, we are looking for whatever is common to all three pieces. So start with the number. I see 10, 25, and 5. So we can pull a 5 out of all of those. 5 goes into all three of those numbers. What about the a's? I see an a cubed there, but only a single a there and a single a there. So only a single a, or a to the 1, we just don't bother to write the 1, comes out. That, if you imagine that this is 3 a's being multiplied, right? But this is just 1 and 1. We can pull 1 out of all three terms. And as for the b's, I see a b squared, a b to the 5th, and a b squared. So I can pull a b squared out of all three of those. And now we ask ourselves, what's left over? Technically, what we're doing here is we're dividing. So whichever way you think about it easier, you go ahead and do it that way. Most people will look at this saying, I pull a 5 out of 10. 10 divided by 5 leaves 2 behind. And then I pulled 1a out of the a cubed, so that means a squared. 2 of the a's are left, a squared, a times a. In the second term, I pulled 5 out of 25, leaves 5, and you see that negative sign travels down as well. And I pulled a out of a, so that's divided out completely, and I pulled b squared out of b to the 5th, that leaves b cubed. Now again, if I talked about that in the division language, which is technically what's happening, if you prefer that, negative 25 divided by 5 is where the negative 5 came from. A divided by a cancels out. B to the 5th divided by b squared becomes b cubed because you subtract the exponents. Either way, in the last term, oh, look at that, I pulled everything out. So this is a little reminder. People will often not write anything there because they think if you pulled everything out, nothing is left. That's not true, because remember, technically you are dividing. So when you divide 5ab squared by 5ab squared, you actually are left with a plus 1 at the end of that bracket. That's an important one, common mistake. Factoring by grouping is a funny little one that only comes up sometimes. Remember, what we do is we look at just the first two and the second two and factor them both separately, which is something you normally would not do. You wouldn't pull common factors out of some but not the rest. You would only pull out common factors if they come out of everything. But in this one exception, and you look for it when you see the 4 terms, it actually ends up working out for us, and we'll remind ourselves of what the special condition is in a second. So let's see, I can pull a 3x out of both of the first two terms, and I can pull a 4 out of the second terms, and reminder that you take that negative with it. Oh, sorry, I got ahead of myself. Pull 3x out of 3xy, there's just a y left. Or if you want to think of it as dividing, divide 3xy by 3x. The 3x's cancel and you're left with a y. 6x divided by 3x is just 2. Over here, this is what I was saying before. We have a 4 that comes out of both. We need to take that negative with it. You'll see why in a second. Negative 4y divided by negative 4 is y. Negative 8 divided by negative 4 is positive 2. And here's where you see whether or not this actually does work by factoring by grouping, because we see those two things that are left behind match. If that doesn't happen, then you can't do it by factoring by grouping, unless possibly you can rearrange the terms and try a different way. And what we do is we consider that whole purple bracket as something we can pull out front from both terms, common factor that whole bracket out, and you can see in black what's left behind when you do 3x minus 4. And then lastly, a difference of squares. We look for a special pattern. We notice that the first term, 25x squared, is a perfect square. It is something times itself. 5x times itself is 25x squared. And the second term is also a perfect square because 1 times itself is 1 squared, or 1 times itself is 1, sorry. So we have a perfect square minus a perfect square. We learned a special pattern that will just be the first minus the second times the first plus the second. And notice what's going in there is these things that are being squared, the 5x and the 1, not the 25x squared. Okay, so that's the 3 we did last time. Here is our 4th type of factoring. We call this factoring trinomials. Trinomial, tricycle, triathlon, tri is triceratops, is Greek for 3. And so trinomials are polynomials that have 3 terms. Take a look at every one of these. X squared, 7x, and 12, 3 terms. P squared, negative 8p, and positive 15, 3 terms, right? So every one of these has 3 pieces separated by adding and subtracting, 3 terms. So we're going to learn to factor stuff like these ones here. And I think once we've done them all, I'm going to put this slide back up and get you to try these ones. So in order to figure out how to do these, because it's not obvious, we're going to start by, once again, by expanding some brackets first and see if we can recognize some patterns. So here's some more great expanding brackets practice, the first half of chapter 6. Give you a minute and remind yourself how to expand those brackets there. And if you can see any patterns developing, try to make note of those. Okay, so we're back to practicing expanding brackets. Why? Once again, because we want to spot patterns so we can reverse the process of expanding brackets. So remember, when you have 2 things in the first term and 2 things in the second, or any number of things in each of the terms, we take every single thing in the first term and multiply it by, we take every single thing in the first bracket and multiply it by the entire second bracket. So you see we took the red t and the blue plus 5, and we multiplied each of them separately by the whole second bracket. T multiplies in, giving t squared plus 2t, and positive 5 multiplies into the second bracket, giving positive 5t plus 10. And I'm going to keep reminding us that there technically is a plus sign out front there and a plus sign out front there. And sometimes that is very critical. So you always think about whether or not you need to write it. For example, this and this is a repeat, but often people will look at this and they'll just say 5t plus 10 instead of plus 5t plus 10, reminding themselves that this is being added, right? So the only time we drop that positive sign is when there's nothing at all in front of it. We look at that and we see that the middle 2 terms collect. 2t plus 5t is 7t. Okay, there's the first one expanded. Same deal on the second one. We take z and multiply it through the second bracket, and minus 3 and multiply it through the second bracket. Z times z minus 9 gives z squared minus 9z. I'm going to go through these pretty fast because this is not the point of this lesson, right? We already did this in an earlier lesson. This is just a reminder. Negative 3z plus 27, negative 3 times negative 9. And the middle 2 terms collect. Negative 9z and negative 3z is negative 12z. And same deal on the last one. I'm just going to hustle through these. We end up with u squared plus 14u plus 40. Okay, so there's our expansions. Now, I'm going to wipe out all those middle steps, I think. Yeah, good. And we are going to imagine now that we were given these things on the bottom and asked somehow to get back to these bracketed things up top, right? The exact reverse question. And we're going to do that by trying to see a pattern of where these numbers came from. Where did the 7 come from? Where did the 10 come from? Where did the negative 12 come from, right? So here's what we want to notice. First of all, look at that last number. Stare at that for a sec and my arrows. See if you can see what the pattern is. Okay, so perhaps you notice that 5 times 2 is where that 10 came from. Negative 3 times negative 9 gave positive 27 is where that came from. Positive 4 times positive 10 equals 40. So that last number is always equal to these two times each other. So if we were given this here and asked to try and turn it back to its brackets, for starters, we would know that the two numbers in the brackets have to multiply to 40. Now that doesn't get us all the way there because there's a whole bunch of things that multiply to 40. 2 times 20, 8 times 5, 1 times 40, and the one we want, 4 times 10, right? Lots of things multiply to 40. Multiple things multiply to 27 or 10. But that gets us part of the way there. Now let's look at the middle number. There we go. We just talked about that. That's the last number comes from those multiplied. Where did the middle number come from? Well, very similarly, I think you'll see 5 plus 2, 7. Negative 3 plus negative 9, negative 12. 4 plus 10, 14. The middle number came from those two things being added. So again, if we were asked to go in reverse, we would now be asking this question. We'd be saying, what are some numbers that multiply to 40 and add to 14? And if we could figure out those numbers, we would be able to factor that polynomial. So let's try that. You can read the explanation at the top there. We need to find two numbers that multiply to the last term, positive 6, and add to the middle term, positive 5. Now I started pretty easy here, and you might already see what those numbers are, but let's try and establish a process that we can use even when the numbers get harder. So first of all, I recommend people write that step there, reminding them, basically establishing what their answer is going to look like. There's going to be two brackets with an R at the start of each bracket. Just like, go back here, just like all of these examples, right? Two brackets with the variable at the start of each bracket. And we want numbers that multiply to the last term and add to the coefficient of the middle term. So multiply to 6, add to 5. And when you don't, sometimes you are just going to see them. You're like, oh, I know what those are. When you don't, what you want to do is you want to list all the things that multiply to the last term. So 1 times 6, 2 times 3, and well, that's it, isn't it? Because if you go up one more, you're at 3, and it's 3 times 2, which you've already listed. So there's only two things that multiply to 6. That's step 1, list all of the possibilities. And then step 2, add those together to see which one of them adds up to positive 5. 1 plus 6 is 7. That's not right. 2 plus 3, there it is. 2 plus 3 is 5. So there's our winner. The numbers are positive 2 and positive 3. And you see yet again how lazy we are. There's really a plus sign in front of every one of these, but we're too lazy to write it. But that is positive 2 and positive 3 are the winning numbers. They multiply to positive 6, and they add to positive 5. Pop them in, and you are done. And that, you factored your first trinomial. So find two numbers that multiply to the last term and add to the middle term. And we have turned one with 3 terms into two multiplied brackets. Let's take a look over here. Again, set up what your answer is going to look like. We want numbers that multiply to positive 18 and add to, okay, let's think about this, add to negative 9. Okay, well, let's start by listing everything that multiplies to 18. 1 times 18. 2, does 2 go into 18? Yeah, it does. 2 times 9. Does 3 go into 18? Yes, 3 times 6. Does 4 go into 18? No. Does 5 go into 18? No. Does 6? Oh, I've already got the 6, so I'm done, right? So there we go. There's our 3 possibilities of things that multiply to 18. Now, here's the problem we identified. We want these to add up to negative 9. Well, if we add two positive numbers, 2 plus 9 is 11, 1 plus 8, those are positive numbers, right? So we recognize that we actually don't have two positive numbers, we must have two negative numbers. Why are they both negative? Because they still need to multiply to a positive 18. If I only made one of them negative, then I'd be multiplying to negative 18, which is no good. So I identify that I'm multiplying to a positive, but I'm adding to a negative, therefore they must both be negative numbers instead of both positive numbers. And now let's add those up again. Negative 1 plus negative 18 is negative 19. That's not the one we want. Negative 2 plus negative 9 is negative 11. That's not the one we want. Negative 3 plus negative 6, aha, is negative 9. That is our winner. And stop and think about it for a second. Negative 3, and double check yourself, right? Negative 3 times negative 6, sure enough, is positive 18. Negative 3 plus negative 6 is negative 9, right? So we found the two numbers that multiply to positive 18 and add to negative 9. Once you found the numbers, you just pop them in there. N minus 3, N minus 6. And if you're at all uncertain, re-expand that bracket and make sure it matches the original question, because when you multiply n minus 3 times n minus 6, you should get n squared minus 9m plus 18, because we are just reversing that process. Okay, there's our first couple easy ones. Why don't you guys try one? So I've given you your first setup step there. This is going to turn into d plus or minus something times d plus or minus something. See if you can find the numbers that multiply to 40, positive 40, and add to negative 14. Okay, so let's see. We want to list off all the numbers that multiply to 40. Let's just start with multiply to 40 without worrying about negatives. 1 times 40. 2 goes into 40, yes. 2 times 20. 3, nope, doesn't go into 40. 4 times 10 goes into 40. And 5, oh yeah, 5 times 8. And I think if you try 6 and 7, you'll find they don't go into 40. And then after that, you're back at 8, which you already got. So there we go. Those are all of our possibilities. And we want to multiply to positive 40. Good. And add to, oh, we want to add to negative 14. Well, adding two positive numbers will never get us to a negative number. Therefore, these must all be negatives. And again, why are they both negative? Because they still have to multiply to a positive. So I can't just switch one of them, because then they would multiply to a negative, right? Once we get to negatives at the end there, then we will have one positive and one negative. Okay, now let's add those together. Negative 1 plus negative 40. Nope. Negative 2 plus negative 20. Negative 22. Nope. Negative 4 plus negative 10. There it is. Negative 4 and negative 10 are the magic numbers that multiply to positive 40, negative 4 times negative 10, and add to negative 14. Put them in, and you have factored that trinomial, d minus 4 times d minus 10. And we're going to remind ourselves we can always check our answer. So if you're thinking, I'm not sure if I got that right, take your answer, d minus 4 times d minus 10. And we're going to take the red d and the blue minus 4 and multiply them both into the entire second bracket, like so. I get d squared minus 10d minus 4d plus 40. The middle terms collect, negative 10 and negative 4 makes negative 14. Look at that. That's our double check. Now don't do, by the way, some people will factor it and then immediately expand it underneath. Don't do that because it makes me think you don't know what you're doing, right? This here in the box is the answer. If you want to do this, this is just off on your rough work as a double check to make sure you got it right. Okay, so far we've had all positive numbers at the end. Let's see what happens when we have a negative number. It is exactly the same, but what do we do to multiply to a negative? We need one of each, right? We need a positive and a negative. So we're looking for two numbers here that will multiply to negative 36 and add to positive 5. That's a little harder to think about. So here's where listing your options really helps, right? You know, like imagine our first example, two numbers that multiply to 6, add to 5. It doesn't take you long to come up with 2 and 3, right? 2 times 3, 2 plus 3. Multiply to negative 36, add to positive 5. That's a little harder to think about. So let's first just list everything that multiplies to 36. 1 times 36. 2 times 18. 3 goes into 36. 3 times 12. 4 goes into 36. 4 times 9. 5 does not. 6 does. 6 times 6, and that's as far as we have to go. So there is all of the possibilities that will multiply to 36, but we actually need to multiply to negative 36. So one number in each of these pairs has to be negative. Which number? Well, they're going to add up to positive 5. So if I go positive 1 plus negative 36, I'm going to get a negative number, right? In other words, to add up to a positive, the bigger number has to be positive and the smaller number negative. Check these out right now. When you add these up, each of these, because the bigger number is positive, each of these will add up to a positive, which is what we need. Let's check them now. Negative 1 plus 36 is 35. Negative 2 plus 18. And if you're not sure, if you're like, wait, it says times, why are you adding them? Remember, this is how I figured out what our options are that multiply to negative 36. And now I'm adding them to figure out which is the pair that also adds to 5. Negative 3 plus 12 is 9. Negative 4 plus 9. Oh, that's looking like a winner. There we go. Double check. Negative 4 times 9 is negative 36. Yes. Negative 4 plus 9 is positive 5. Yes. So k minus 4, k plus 9. By the way, if you wrote k plus 9 times k minus 4, that would be totally fine as long as the plus is with the 9 and the minus is with the 4, right? The order of those brackets doesn't matter, just which sign goes with which number. Okay, that wasn't too bad. Here's another one. You give that one a try following the same process. If you're still a little confused, just start by listing everything, every pair that multiplies to 48. Okay, so what do we want to do? Big picture, we want to find the two numbers that multiply to negative 48 and add to negative 8. How are we going to do that? Well, if they just jump right off the page at you, if you just sometimes see them, great. Oh, it's positive this and negative that. But if not, just start listing all those things. 1 times 48, 2 times 24, 3 times 16 is 48. And again, you can use your times table or your calculator to quickly do this. You don't need to, know them all inside out. Does 4 go into 48? Again, check it, right? If you're not sure, you don't need to sit there and stare at the paper and wonder if 4 goes into 48. Pick up your calculator. 48 divided by 4. Oh, look at that. It does, right? That's all you have to do. Does 5 go into 48? No. Does 6? Yes, 6 times 8 is 48. The easiest one to memorize on the times table sheet. So let's look now. These all multiply to 48, but of course I want to multiply to negative 48. So 1 in each pair has to be negative. Which one? Look over here. We want them to add up to a negative number. So I need to make the bigger number negative. Otherwise, they will add up to a positive number. So this time, I make all the bigger numbers negative. Now I'm going to check which of these pairs that multiplies to negative 48 adds up to negative 8. So 1 plus negative 48 is not it. 1 plus negative 24 is, well, that's incorrect. That should be 22, but that's not our answer anyways. Sorry about that typo. 3 plus negative 16 is negative 13. 4 plus negative 12, 4 plus negative 12, there it is, adds up to negative 8. So there's our numbers, positive 4 and negative 12, just like so. Oh, and just to show you, look at this, I reversed the order, right? It doesn't matter which bracket goes first as long as the negative is with the 12 and the positive is with the 4. Oh, we're going to double check this one. I don't think we're going to pause. I want to keep moving. This is taking a while here. So just quickly show the expansion. If we were to take our answer and re-expand it in the middle, at the end there, you got that negative 48, right? Negative 12 times 4. And in the middle, plus 4 and minus 12. That's where the negative 8 comes from, right? So you can see why this method works, because that's exactly what happens when you expand the brackets. Okay, sometimes you'll see something like this and it's identical question. Don't panic. So what's different here? Well, instead of one variable, we have two variables. One is squared out front, the other is squared at the end, and the middle term has one of each. When you see that, it is the identical process. But instead of having s plus something and s minus something, you're going to have an s and a t in each bracket. So set it up like that, just like we did before, but now there's an s and a t. And then find your numbers in exactly the same way. Yeah, sure. Take 30 seconds to see if you can find those numbers. Okay, so let's list everything that multiplies to 54. 1 times 54, 2, well, it's even, so yeah, 54 divided by 2 is 27. 3, check on your calculator if you want. 54 divided by 3, oh yeah, 3 times 18 is 54. 4, check your calculator, no. 5, no. 6, yes, 6 times 9 is 54. There we go. But we want to multiply to negative 54, so one of them is negative. Look over here. They have to add to a positive, so the bigger one is positive and the smaller one is negative, like so, to make them add to positive numbers. Check what they add to now. There's our winner. Negative 6 plus 9 is positive 3. So the numbers are minus 6 and plus 9. Put them right in there in front of the t's, just like that. And if you want to check that expansion to see that it works, you'll see how that all plays out. The middle term has two different st pieces that collect together. I'll leave that for you to try. Oh yeah, this is important. So look at that middle term there, plus m. It looks like it doesn't have a coefficient, but of course we know it does, because when we are too lazy to write the coefficient, we know that it is a plus 1. So when we don't see the coefficient there, remind yourself it's plus 1. Let's follow our same process now. We're going to have two brackets. What are all the different things that multiply to 2? Well, that's it. 1 times 2, right? But we do see that it's a negative 2, so one of those has to be negative. Look over here. They have to add to a positive, so the bigger one has to be positive and the smaller one negative. Well, those had better work, because if they don't, there's no other option. Let's try it. What is negative 1 plus 2? Oh yeah, it's positive 1. So there's our numbers, m plus 2, m minus 1. And you see again, I reversed the order of the brackets just to show you it doesn't matter. What's important is that the plus is with the 2 and the minus is with the 1. So here's the 4 that we put up at the start. And I'll tell you what, if you want to give these a try now or after class, you can. And what I will do is at some point I will go through those. Maybe I'll put up the answers on the screen during class, and then after class I'll quickly record me going through them and tack that on to the end of this video. Okay, we're going to tack this on here to the end of the other video. I'm doing this after class. These are the 4 examples I left you with to try your trinomial factoring. So let's go through them fairly quickly here. So on the first one, we know we're going to end up with 2 brackets with an x in each. We are looking for numbers that multiply to 12 and add to positive 7. So 1 times 12, 2 times 6, 3 times 4. There's our options of what multiplies to 12. Now, which one of those 3 adds to 7? It's going to be 3 plus 4 is 7. So 3 times 4 is 12. 3 plus 4 is 7. So the numbers are positive 3 and positive 4, like so. Second one over here, we're looking for numbers that multiply to positive 15 and add to negative 8. Well, we already know we're going to have negative numbers, so let's first figure out what multiplies to 15. 1 times 15 or 3 times 5, those are the only options. If we want those to add up to a negative 8, then we actually know they're all negative numbers. Why are they all negative numbers? Because if we had negative 1 times positive 15, it wouldn't be positive, it would be negative, right? So we need 2 negatives to multiply to positive 15, and we need them to be negative, so they add up to a negative over here. And negative 3 and negative 5 adds up to negative 8. So there's our numbers. Double check. Negative 3 times negative 5 is positive 15. Negative 3 plus negative 5 is negative 8. Yes, those are the numbers. Next one here, we want to put the b's in there. I guess I forgot to write the b's down. We want to multiply to negative 8 and add to 7. So there's options for what multiplies to 8. But we want to multiply to negative 8, so in each of those, 1 has to be negative. How do I know which one? Well, I want them to add up to positive 7, so I need the bigger number to be positive, otherwise they will add up to a negative. Now let's try negative 1 plus 8. There we go, that's the winner. Double check. Negative 1 times 8 is negative 8, yes. Negative 1 plus 8 is positive 7, yes. There we go. Last one, well, we see we have the special one with the 2 variables, and a couple special things here. First of all, we look there, and there's no coefficient. That doesn't mean 0. That means we know there's a 1 there in front of that VU. And our brackets are going to have both of the letters in there. That's the only difference for these ones. You put the V and the U in the bracket. We want something that multiplies to 30. Let's start with that. There's all of the options of anything that multiplies to 30. But we notice we want it to multiply to negative 30. Okay, we want the bigger or smaller number in each pair to be negative. Well, we want them to add to negative 1, so we want the negative number to be bigger. There we go. There's a bunch of options for what multiplies to negative 30. Add them together. There is the one that adds up to negative 1. Positive 5 plus negative 6 is negative 1. So those are your numbers, plus 5 and minus 6. Just like that.